Okay, so we're going to talk about section 7.1 of your math analysis textbook here, which is going to start looking at some conic sections. Specifically for this section, we're going to look at parabolas. So as we're going through this, we're going to look at what we've done before, where we've just looked at graphs of quadratics, and then we're going to adjust those using a different kind of formula for our graphs. So now we're going to analyze and look at the graphs of these parabolas. Okay, so again, we're going to look at the equations of parabolas as we move forward with this. So as we're looking at this, we're going to use this idea of a conic section, and a conic section comes from taking a cone. So if we have a cone shape, something that looks like that, and it goes back in space. If we were to slice it up like this, what we get is this parabolic shape, and that's kind of what we're looking for to start with this here. And we'll go through those as we get to different conic sections, different ways to slice that. So we have a locus of points, we're going to have a parabola, we have a focus, a directrix, and then an axis of symmetry, and then a vertex. So these shapes you should be familiar with. We're just going to add kind of to the complexity in terms of terminology, right? We have a parabola, it looks like a U. We have a vertex that's down the bottom. We have an axis of symmetry, and then we're going to add some points called a focus and a directrix and see how those work together to actually form that shape, that parabola. In general, what we're looking for this is something in the form either y equals x squared, so we have a squared term, or x equals y squared. When we see one squared term, we're going to get a parabola as our output. All right. So this is our kind of general definition that we're going to look at. The picture I just kind of sketch out for you. What we have is a parabola is a collection of points that are equidistant, right, from this focus point to the directrix. So this line, the pink line, and the pink line are the same length. If we were to collect all of those points and get at a collection of points, so from there to there, and then closer and closer, all of those points, those collections are going to form the parabola. It's going to form that whole shape. And so that's really what we're looking at, is this collection of points that are equidistant from a point called the focus that's in the middle, and then the directrix, which is going to be a vertical or a horizontal line that is on the other side of the vertex, and then the vertex is in the middle of those 2 points. This is our general equation. So these are going to be super helpful for you to look at as we're going through this. So they're on your notes, and you should be able to have them as you go through it. But basically, again, this gives a little bit more of an equation to it as we're looking at it. So if we have a parabola that goes up or down, what we're going to see is that's going to be an x squared term. All right, h and k are the center points, all right, of the vertex. So that goes to that vertex point that's on our parabola. Now the focus is going to be up. We're going to add a p-value, and the directrix is going to subtract a p-value. And that p-value shows up right here as 4p. So with those values, with having the center and then how far away are we from the focus and how far away are we from the directrix, that value of p, we're going to be able to sketch a parabola. If we have one that is going left or right, so left or right, what we'll see is we have a y squared term. So this is a y squared term. Same thing with our center points. So k and h become our vertex, so right there. And then we add, since we're going the x direction, we're adding a p-value, and then we're subtracting a p-value to get to the directrix. Now we can notice with both of these, if p is negative, when I add a p-value, so in this case over here, if p is negative and I add a p-value, I actually go down. And so that will actually turn the parabola to go down. On this one, if I add a negative p-value, it goes over here, and then I'm going to get it to go to the left. So that will be what kind of moves our things around from left to right or up or down. Okay, there's a couple of kind of demonstrations we can look at of how this looks. So the first one is just showing kind of what we just talked about of this collection of points. So if I change this value of a, again, a parabola is where this line, the blue line, and then the orange line are equidistant from the focus, which is right here, and then the directrix, which is the green line down there. And so if I run this, what we'll see is those values grow. Those are all the same, and it moves back and forth from there. So that collection of points sketches out our parabola. If we let A go infinitely in both directions, we'd see that we get the whole curve. So we can stop that for a second. And what we can also see is that what happens with the value of P. So right now P is positive, so that when I move up, right, I get the focus on this side. If we allow P to get bigger, we're going to see that it gets wider. And then as P is going to flip here, it's soon going to go negative. And so then adding a P value is going to move to the other side of the vertex. What we're going to see is that the parabola is going to actually flip around. So I'm going to run it, and now it's negative, and then there we go. So now adding P to the vertex actually brings it down here. So my focus is down here, my directrix is above it, and that makes it go up and down. If we wanted this to go left and right, what we'd do is instead of an x squared term, we could have a y squared term. So that's kind of how those pieces look. Now, when we start to, this is another demonstration, is if I move the center point around, so if I move that x value, right, we can see that that moves that vertex and the focus to the left or the right. If I change the value of P again, a bigger P value makes it wider. It spreads out that distance. A smaller P value makes it narrower, and then a negative P value is going to flip it over. All right, if I move the K value, that's going to move the center point of the Y value up and down. So I can adjust the P value, I can adjust the H value, that center point, and I can adjust the K value to move it up or down. So those transformations still are intact as we're looking through this for our parabolas. All right, so let's look at kind of some of the math as we go through this. Again, we're basically fitting all these back to this original equation as we're looking at this. So trying to find that p-value, trying to figure out what our center point is. All right, this is the graphic from the book. Same thing that we had before. What we want to notice is that we have also an axis of symmetry, which is that point down, that line down the middle. If we were to fold the parabola over, we would have it line up on top of itself. So if I have a vertical line of axis of symmetry, I'm going to have a horizontal directrix, and then vice versa. If I have a vertical directrix, I'm going to have a horizontal line of symmetry. Those are going to cross each other at right angles. All right, so let's say we've been given this and we want to figure out what it is. So first and foremost, I see there's one squared term, so it's going to be a parabola. And further, I can see that it's a y squared term, so that's going to open to the left or the right. So we're going to try to put it in our standard form and then figure out the center point and then the value of p. That value of p is going to allow us, again, if we have a graph that looks like this, so it's either going to go left or right. There's my vertex, there's my directrix. My focus is on that side. I need to know what P is on that way, and I don't know what P is on that way, and that will allow me to sketch my graph, assuming that it opens to the left or right. And again, P being positive or negative is going to determine where it looks like that or whether it's flipped over there. All right, so we're going to go through the math and kind of see what fits. Right, we have the standard form that we looked at on those graphics before. Right, so 4p is -8, which means p is -2, which means that when I add p, it actually takes me to the left. So if I was to draw this one, I have my axes, and then I have some center point. We haven't looked at it yet. Some vertex, sorry, and then when I add P, it actually takes me that way. So my focus is over there, my directrix is somewhere over here, and that's where I'm going to get it opening up to the left. All right. There's my values for H and K, right? Subtracting, again, pay attention to what you're actually subtracting. So if I have a positive, if it's a positive value here, it's actually going to be a negative value there. Just like I have a positive 1 here, so I'm subtracting a -1, which is why I get a -1 there. So that becomes my center point. I have the P value, and I can sketch everything else that I need. All right, so that's my vertex. There's my focus, again, adding P to the X component, and then my directrix when I take it away. And then my axis of symmetry is in the middle. And so when I graph it, I use a table of values. There we go. All right, opens to the left. I have the vertex, I have the focus, I have the directrix. And I can see kind of what those values are pretty easily when it's in standard form. All right, so you should pause the video at this point, and then you're going to do the guided practice problem. So you have an equation, you need to make it in standard form, figure out if it goes up or down or left or right, what's the value of P, what's the center point, and then sketch those values. Okay, here's another example. I've been given something that's not in standard form, so I need to take this and then turn it into standard form. When I look at this, I notice I have one squared term, so it's going to be a parabola, and it's an x squared term, so it's going to go up or down. So I'm looking to put it as x quantity squared. I'm going to have the y values on the other side, and again, I'm looking for that value of 4p, so I know if it goes up or it goes down based on the sign of p. So the way that we're going to do that is we're going to bring the numbers to the one side. We're going to leave our values of y and x on both sides. So we're going to basically get those values together. And then we need to look at this x squared minus 8x term. And we're going to see how can we complete the square to get a quantity on that side. So when I look at that, I multiply by -1 to get a positive term here. And then I need to complete the square. So I take half of this value, so half of 8, which is -4, and then I square it to get 16. So I need to add 16 over there, and I'm going to factor that side. All right, so I get x minus 4 squared plus 2. Right. Now, that doesn't really make sense if we look at this. This was, if I have my value here, okay. What they've kind of skipped over here, what we need to be a little bit careful of, if I've added the 16 on this side. So when I added 16, that's great, because that will turn into that. But then my 18 turned into a 2 somehow. So what they really did is when we added 16 there, we have to add 16 to the other side. But since we want y to itself, we're going to take away 16 so that we're left with that over there. So this is when we subtract 16, 18 minus 16 is where the 2 comes from. So that, don't be alarmed when you see that. Another way to write that is we would do x squared minus 8x plus 16 minus 16, so we're just adding 0 to one side, plus 18, right? This turns into quantity x minus 4 squared, and then -16, 18 is plus 2. That's where that value is coming from. So just be careful when you complete the square that you need to add the quantity to both sides. All right, now we have this value in, we're taking away the 2 to put it into our standard form, and we can see that it's an x squared term, which means it's going to go up or down. We need to figure out what's in place of 4p, find that, and then we have our value for our focus and our directrix. All right, so there's our value. We can see that 4p has to be 1. Because we have 1 in front of it. And so when I get that from here, right, if 4p is 1, then p is 1/4, which is 0.25. So that's where the 0.25 is coming from. Well, now that I have it in this form, I can see I have my h and k values, which are going to give me my center point, and then with the p value, I can figure out the directrix and the focus. All right. When we graph it, we can see that we would have a table of values, and then as I graph it, there we go. So we have our center point, we have our focus, and we have our directrix, all that we can find using h, k, and the value of p. Again, all that comes from completing the square. All right, so you need to do this one on your own. This is our guided practice problem. Something to keep in mind is it's one squared term, it's a y squared term. So you're going to have it go left or right. You want to bring the y's to one side. You're going to complete the square to get it into factored form. And then x is on the other side. You're going to find what's in the place of 4p, figure out what p is, and then you can use the center point in the value of p to sketch your graph. All right, well, this is a little bit different in that we haven't been given the equation. What we've been given is some characteristics, and we need to then determine what the equation is. So I know that a vertex is at 3, -2. So if I was to just sketch out what I've been given, right, I know at 3, 1, 2, 3, -2, there's my vertex. And I know I have a directrix at y equals -1. So y equals -1 right there. All right, so I can never cross a directrix, which means that I'm going to have my parabola is going to have to go down like that. Whatever this distance is, so whatever that distance is, that's my value of p, and I know that my focus is going to be the same distance away in there. So from there, I can start to figure out where my values are going to be. So just given that, I know that I'm going to have a y-squared term, it's going to go down, and I know where my center point is. So we just go through the mechanics of that. All right, so a horizontal line, it opens vertically. Because the directrix is above it, it goes down. That's what we just sketched. All right, so we use our equation. We figure out where the directrix is, and then we add, from there we can figure out what P is, right? And we see that it's going to give a value here. We put in the standard form where we know it's up or down, so it's an x squared term, right? It's not a y squared term. There's our general state, and then we plug in the values that we know for h, k, and then the value P that we just found. All right, there we go. As we get it there, so that looks like our standard form for that parabola. We can check it by graphing it, either on the graphing calculator or again going back through the center point and then p-value. There we go. So from there, you can just, given the characteristics, you can figure out what the equation would have to be. Right? And then the table, you get the graph. It looks like we expect it to. It has the right vertex, it has the focus, and it has the directrix. Okay, here's another one where, again, we've been given different values, where we've been given a focus. So I know the focus, and then I know it contains a point. Now, one thing to think about as we're looking at this is this point is an XY value. It is not necessarily the vertex. So we can't assume that that is our vertex value. We're going to have to use some values to kind of come up with a general form, and then from there we can figure out where the vertex is, which gives us h and k. So when we look at this, right, we know that it has that focus at this point at -1, 7, and then we know that from there, okay, there's our vertex. So from here, we can know that 7 minus p is going to be the vertex, and we use this general point of x and y to find the equation. So we start with our general equation, right? We plug in the general point of 3, so we know that x can be 3. When x is 3, y is going to be 7, and we get this equation where k equals 7 minus p, which has 2 variables in it, right? We can simplify, right, by collecting terms, and then we divide by 4 to get p. So plus or minus 2 is going to be our value of p. Because it opens up, then we know that it has to be positive, so p has to be 2. And so that we can there figure out where our vertex is, so we can have the property that if I know where the focus is, so I have the coordinates of the focus, and I then can figure out that I have a difference of p there, that's the vertex, and then I can solve for where the vertex is. And once I have the vertex, it's not too hard to get it into the standard form of a parabola. All right, and then they have their graph and they verify that it looks the way that it should. All right, so for this one, again, you have been given some values. You've been given the focus and the directrix. And what you're going to look at is, I know if the directrix is, again, sketch it out. You know that your directrix is at x equals 4, which is going to be a vertical line. So you know it's going to open to the left or the right. If you know that the focus is at -2, 5, okay, so if we go back -2 and then up at 5, there's your focus. Your vertex is going to be in the middle of that, wherever that would be. So that is going to give you the coordinates of your vertex, and you know that this distance, whatever that is going to be 2p long. And from there, you can figure out what your equation is going to be by plugging into the general equation of a parabola. All right, last concept here is if we've been given, we go back to the kind of definition of a parabola, which is that we have a collection of points that's equidistant from that focus to that point. So we have this triangle that we can form from a focus to a point, and then that line that we have through there. All right. So as we look through this, we can use that geometric property to solve problems. Okay, so we have an equation for our x term. We know it's going to go up or down. and we know that we want to find the equation tangent to this point that should be on our parabola. We can see if we put in 2 for x, 2 squared is 4, 4 minus 2 is 2, so it's going to work for those values. So basically we're going to draw that isosceles triangle to get 2 points on a line, and then once we have 2 points on a line, we use y equals mx plus b, or other standard forms of a line where we have a slope and an intercept, or a slope and a point, to get the equation of the line. All right, so that's what they do. They go through this, they determine the vertex, and then they get a value of p. Sorry, let me go back there. Because we're multiplying by 1 in front of that squared term, we have for p is 1 or p is 0.25. So we can get our vertex and then the focus. So once we've gotten the focus, okay, we use the property that they just talked about of this isosceles triangle. So this value, that length, and that length will form the line that goes through them. And to get the equation of the line, we need the slope, so our rise and our run, which is our m value, and then we need a point on it, which thankfully we have one there, and we have one there, which can get us our point slope formula for a line. So that's kind of where they're headed with it. So what we do is we have our values there, and we figure out one of the legs of the isosceles triangle using the distance formula. So just taking the square root of the subtraction of the square root of the points, and we get that distance. All right. From there, we can drop down to find that point that was pointing down along the axis. All right, so we can get that coordinate. Now that we have 2 coordinates on the line, so the point that was given, which was 2, 2, and then the point here, 0, 6, we can determine the equation of the line by finding the slope, and then by finding with the slope, we use our point slope form, plug it in, and we use the point that was given, 2 and 2, and then that becomes our equation of the line that goes through those points. All right, so you can manipulate from there to get y equals mx plus b form, or if you want to just leave it in point slope, that's fine. All right, so you're going to try this one out. You're going to write the equation of line tangent to that at that point. You're going to have to determine whether it goes up or down, left or right, and then you're going to need to find the distance between the point that's given and that focus point to give you the value that you're going to drop down to find the other point of that isosceles triangle. All right, good luck.